Hi, good afternoon to one and all who are all separating a setup, who are set up a separate time to view of this video. Hereby we are going to see a slight description of about outline and overviews of concrete technology. I'm going to just give an introduction of about the outline and overviews of concrete technology. The introduction was, since the word concrete is a polysim, here we consider this word as a noun. Study of concrete as a here we going to study the concrete as a construction material that's previously described as a noun, and key aspects are materials, mixed design, production, properties, testing and quality control, and types of concrete, innovative technologies, and some of its applications, and particular denominations of about concrete. That means the concrete ingredients are cement, which behaves as binder, and aggregates are filler, and water acts as lubricator, and some admixtures if necessary. And concrete is a two-phase system. The expressing the mix ratio of concrete is based on the principle of arbitrary method, as like arbitrary means it's like a dependent sequence of about 1:n:2n. Example M25, which we going to describe as 1:1:2, and for 115, which is as 1:2:4. And the production of cement, the raw materials of cement are limestone, clay minerals, clinker, and gypsum. The chemical name of gypsum is calcium sulfate dihydrate, which means the gypsum is a new word. While the first time if a person first time going to study about concrete technology, the gypsum is a new word for them. So here I given a chemical name of it. The chemical name of gypsum is calcium sulfate dihydrate. Initially, clay and limestone are heated at 1000 degrees Celsius to liberate carbon dioxide out from limestone and get calcium oxide. Then the calcium oxide and clay are heated at 1400 degrees Celsius at kiln to transform them into molten state. Finally, the calcination process required to extract clinker from the kiln. The calcination means extract out the carbon dioxide out from the byproducts of the previous steps. And now we are going to see about some descriptions of about cement. In 1824, Mason Joseph Asphodin invented the cement. Specific gravity of cement is equal to 3.15, and cement. Previously we seen about the clinker, which means without gypsum, the clay minerals and limestones are added together called as clinker plus gypsum. If gypsum gets added less than 2% or more than 5%, it leads to cement to set in a flash. In cement, tricalcium aluminate is highly unstable. When it reacts with water, flash set occurred. Fineness or specific surface area of cement, which means the perimeter is like a perimeter of a small atom molecules of cement, which is 2250 to 4000 centimeter square per gram. And the types of cements are, there are too many types of cements, but here we are going to see some important types of cement. Ordinary Portland cement, which is abbreviated as OPC. The fineness of this OPC is 2250 centimeter square per gram, and initial setting time is 30 minutes and final setting time is 10 hours. Portland Pozzolano cement, which is abbreviated as PPC, and OPC gets added to 15 to 35% of silica and alumina is called as Portland Pozzolano cement. The silica and alumina is also a small, sometimes it's called as fly ash too. natural pozzolano, if the OPC added with volcanic ash, it is called natural pozzolano. If it is added with fly ash, it is called artificial pozzolano. Rapid hardening cement, the high early strength cement, higher composition of tricalcium silicate. Low heat cement, the higher composition of dicalcium silicate and lower composition of tricalcium silicate and dicalcium aluminate. There are four major components composition of cement, which is additionally together called as the clay minerals, which are these four are the items: tricalcium silicate and dicalcium silicate and tricalcium silicate and dicalcium aluminate. These four are the major composition of clay minerals which going to add into cement particles. And types of cement is continued as previously we stopped with low heat cement, and then it's going to continue with it as sulfate resisting cement, higher composition of tricalcium and dicalcium silicate and lower composition of tricalcium and tetracalcium aluminum ferrate, and some other types apart from these five, and some other types of cements are Portland slag cement and high alumina cement, quick setting cement, white cement, colored cement, hydrophobic cement and air entraining Portland cement. Important chemical compositions of OPC are: lime 60 to 65% controls soundness and strength of the cement. When the cement is converted into concrete, the same composition will be maintaining the soundness and strength of concrete also. Silica 20 to 25% gives strength, and alumina 48% responsible for quick setting, and iron oxide 2 to 4% which imparts color, majorly prefers to ash to red, and magnesium oxide 1 to 3% imparts hardness, and sulfur dioxide 0.5 to 3% for soundness, soda and potash 0.4 to 1.3% for soundness, and gypsum 2 to 3% delays the setting time. By adding the gypsum, we could accelerate the setting time. If it's reduced to 2% or gets increased of about 5%, the setting time will be accelerated and leads to quick set. If the gypsum is maintained between 2 to 3%, the setting time will be delayed. Hydration of cement, which means the reaction between cement and water. Calorimeter is used for measuring hydration, and code of practice IS 11262. The year belongs to 1985, and unit of heat of hydration is calorie per gram or joules per gram. 1 calorie is equal to 4.1 joules. Heat produced in hydration process is called heat of hydration, which means the reaction between cement and water. The heat produced due to this reaction is called heat of hydration. Tricalcium silicate requires 24% and dicalcium silicate requires 21% of hydration. But by SP 23 and 1982 for Portland cement, 23% and 53% requires respectively for filling gel pores, which means the small pores which couldn't be seen with our naked eye, or have to be filled with the cement gel. For that, it requires 23 to 15%, and by adding these two, the total water minimum required for heat of hydration is, which means it's a little bit of mistake. So minimum total water required for heat of hydration is 38%, and the minimum water required for heat of hydration is called chemically combined water or bound water, which means this 38% is also known as chemically combined water or bound water. Functions of Bob's compound. Previously I said there are four major compositions of clay minerals, which are tricalcium silicate and dicalcium silicate and tricalcium aluminate and tetracalcium aluminum ferrate. The tricalcium aluminate is also called as halite, and dicalcium silicate is also known as belite, and tricalcium aluminate is also known as silicate, and tetracalcium aluminum ferrate is also called as pellite. This halite is responsible for early strength and produces more heat of hydration. This belite, responsible for long-term strength, produces less heat of hydration, and the salate, first compound to react with water, responsible for quick setting. Tetracalcium aluminum ferrate, which is also known as pellite, higher resistance to sulfate attack. And now we are going to see the testing of cement, which means the cement, before we going to use it for the preparation of concrete, the particular test have to be conducted to evaluate whether it is ready to prepare for concrete. And for that, the field testings are visual test, adulteration test, and strength test. And the lab testings are fineness test, blame, air permeability test, and normal consistency test, setting time test, soundness test, compressive strength test, and tensile strength test. And the aggregates. Previously, we have seen the aggregates are used as fillers to prepare the concrete materials. The aggregates occupy 65 to 70% of volume of concrete, the major part of the concrete. So it is called as filler. And the crushed granites are used as coarse aggregates, and aggregates reduces shrinkage, classified on the basis of nature of formation, size, and shape. Based on the nature of formation, the aggregates are classified as natural and artificial. Based on its size, the aggregates are classified as fine, coarse, cyclopean, and all in aggregate. And based on its shape, it's classified as rounded, irregular, angular, flaky, and elongated. Particle sizes of aggregates. The clay, previously we have seen, based on its size, the fine, coarse, and cyclopean and all in aggregate. This clay belongs to all in aggregate. The size of the clay, which is less than 0.002 mm, and the size of silt is equal to 0.0022 to 0.063 mm, and the size of fine aggregate between 0.075 to 4.75 mm, and the size of coarse aggregate between 4.75 to 75 mm. And the cyclopean previously we have seen, based on the size, the aggregates are classified as something else. One among them are cyclopean, and its share, the size of the cyclopean are greater than 75 mm, and all in aggregate is equal to fine plus coarse. The fine plus coarse means which is more than 75 mm, and also the fine aggregate also comes along with it. Concrete, we have seen previously the cement and aggregate, while along with the water, these three components are jointly and comparatively called as concrete, and two types by its mixing: ordinary concrete or nominal mixed concrete, and control concrete or design mixed concrete. Classifications are based on grade as per IS 456 and 1978. Ordinary concrete are classified as M10, M15, and M20 and M25. And the control concrete are classified as M30, M35, and M40. And as on our first slide, we have described that M25, by arbitrary process, its ratio are comparatively called as 1:1:2, and for M20 1:1.5:3, and for M15 1:2:4, and for M10 1:3:6. And as per IS 456 2000, previously we have seen about 1978, and on 2000 some corrections are made, as ordinary concretes are classified as M10, M15, and M20, and standard concrete are classified as M25, M30, M35, M40, M45, M50, and M55, and the high strength concrete as M60, M65, M70, M75, and M80. Classification by its state, which means whether by adding the water along with it could produce two phase. One is a molten state and another is a solid state. The molten state is called as fresh concrete or green concrete, and the other one, the solid state, is called hardened concrete. The properties of nominal mixed concrete are grade, proportions, and quantity of water per 50 kg of cement. It's in the manner of a tabulation, which means the first column denoting the grade of the cement, the grade of the concrete, which we are going to see, and the proportions, as I previously said, by arbitrary method, the ratio and the proportions can be described for M25 1:2, and for M20 1:1.5:3, and M15 1:2:4, as on as. And for the quantity of water required per 50 kg of cement, if the cement are packing as 50 kg per bag. Likewise, for per bag, the quantity of water required for M5 concrete is 60, and M7.5 is 45 liter. For M10 it's 34 liters, and for M15 it's 32 liters, and for M20 it's 30 liters. water cement ratio by code of practice IS 456 2000, and by mixed design, for mixed design we have to refer IS 102262. Other properties of concretes are fresh. Properties of fresh concretes are must have to be satisfy these conditions: good workability, no segregations, no bleeding, light and harsh. And properties of hardened concrete are strength, durability, impermeability, shrinkage, creep and thermal expansions. And the tests on concrete that should be performed before we going to before we going to dump it on a field work or site work. For that we have to first conduct on these tests to accredit them as an proper concrete, as well as the test to be performed on fresh concrete are slump test, compaction factor test and VB consistometer test, and test to be performed on hardened concrete are destructive testing, compressive strength test, tensile strength test, and for non-destructive testing rebound hammer test and ultrasonic pulse velocity test. Production of cement concrete. Batching means for picking up soil aggregates and cement by volume or weight manner to the procurements. Mainly the procurements of concrete materials are called as batching. The process of proper and accurate measurement of all concrete materials. Types of batching: volume batching and weight batching. Tolerance of batching: cement can be incremental or increased or decreased by 1% are allowed, and for water 1% are allowed, for aggregate 2% are allowed, for admixture 3% are allowed. And if it gets more than or less than the allowed percentage, the mixing will be not suitable for that abrupt working manner. Mixing. Optimum mixing time is more important. And types of mixing: hand mixing, 10% extra cement to be added. For hand mixing, 10% extra cement to be added in order to get rid of wastage. And machine mixing, number of revolution is equal to 20. Transportation, placing, compaction, finishing and curing. These three are the important process that I have ordered for the production of cement concrete. And now we are going to see about admixtures. Chemical admixtures are plasticizers, reduced water content. The example of that reduced water content plasticizer are lignosulfonate, and for super plasticizers reduce high range of water. Example: sulfonate, melanin, formaldehyde. Accelerators, decreasing setting time. Example: calcium chloride. And retarders, increasing setting time. Example: gypsum. Air entraining agents, increases durability. Example: benzol resin. Mineral admixtures are these five are chemical admixtures, and now we are going to see about the mineral admixtures: cementitious and pozzolanic, blast furnace slag, fly ash, silica fume and rice husk. These are the admixtures commonly used in our country for adjusting its properties as for our own wish and for client wish. Conclusions: as the demand for resilient and eco-friendly building grows, concrete technology continues to evolve. As the construction industry faces new challenges related to sustainability, efficiency and resilience, concrete technology continues to evolve. Now we are going to see a slide revision from the start. As well as I said, the topic of our view was outline and overviews of concrete technology, and I have given the introduction. There are too many words are called as pluralism, which could give so many meaning, and the concrete here also belongs to a pluralism word. Here the word are considered as noun, as the concrete as a construction material, and the key aspects we are going to see are materials and its mixed design, its production and properties, testing and quality control, types of concrete, innovative technologies and applications are the major key aspects of concrete that we are going to see on this subject, and along with its advanced concrete technologies. Now we are going to see about concrete. The concrete ingredients are cement, aggregates and water plus admixture if necessary. Cement behaves as a binder and aggregates are commonly used as filler and water acts as lubricator. Concrete is a two-phase system. The phase 1 was without adding water and phase 2 was adding water, which is a solid and molten state. Expressing the mix ratio of concrete is based on the, which means the proportion mix ratio. As I said, this 1:1:2 and 1:1.5:3. Likewise, the proportioning of concrete is based on the principle of arbitrary method, as like 1:n:2:2n. Example, for M25 1:1:2. This M25 is the first is the least concrete grade which is used which we can use as standard concrete. Production of cement. The raw materials of gypsum are limestone, clay minerals and clinker and gypsum. The chemical name of gypsum is the calcium sulfate dihydrate. Initially clay and limestone are heated at 1000 degrees Celsius to liberate carbon dioxide out from limestone and get calcium oxide. Then the calcium oxide and clay are heated at 1400 degrees Celsius at kiln to transform them into a molten state. Finally, the calcination process required to extract clinker from the kiln. Then the clinker added with gypsum, we could extract the concrete. We could extract the cement. In 1824, the mason Joseph Asphodin invented the cement. Specific gravity of cement is equal to 3.15, and the cement, for extracting the cement, the clinker should be added to with gypsum. If gypsum gets added less than 2% or more than 5%, it leads the cement to set in a flash. In cement, tricalcium aluminate is highly unstable when it reacts with water. Flash set occurred. The final specific surface area of cement is equal to 2250, which means 2250 to 4000 centimeters square per gram. The types of cements are ordinary Portland cement. There are 5 types of cement which are most important types of cement used in our country, and there are some other important types of cements are here. Let me see. The ordinary Portland cements are the properties of ordinary Portland cements are fineness 2250 centimeters square per gram, and initial setting time is 30 minutes and final setting time is 10 hours. For Portland porcelain cement PPC, when the ordinary Portland cement get added to 15 to 35% of silica and alumina, the Portland porcelain cement can be extracted. Natural pozzolano, when the OPC added with volcanic ash is called natural pozzolano. When the OPC added with fly ash, it is called artificial pozzolano. The rapid organic cement, high early strength cement, higher composition of tricalcium silicate. Low heat cement, higher composition of dicalcium silicate and lower composition of tricalcium silicate and dicalcium aluminate. Sulfate resisting cement, higher composition of tricalcium and dicalcium silicate and lower composition of tricalcium aluminate and tetracalcium aluminum ferrate. And the other types of cements are Portland slag cement, high alumina cement and quick setting cement, white cement, colored cement, hydrophobic cement and air retaining Portland cement. The chemical composition of OPC are lime 60 to 65% of overall composition, and it is the major composition of ordinary Portland cement. It controls soundness and strength. Silica 20 to 25% gives strength, and alumina 4 to 8%. It is responsible for quick setting. Iron oxide 2 to 4%. It imparts color. For white cement, iron oxide very least amount that should have to be added. Magnesium oxide 1 to 3%. It imparts color, and sulfur trioxide 0.5 to 3% for it be used for soundness. Soundness means the changes that could occur when the shrinkage occurs, which means it could extract or it could contract or expand when the water could be added, and while setting on both the phases, the volume could have been changed for the concrete. That is we called as soundness. Soda and potash 0.4 to 1.3% for soundness. Gypsum 2 to 3% delays the setting time. Hydration of cement. The reaction between cement and water. Calorimeter is used for measuring hydration, and code of practices that used for elaborately studying about this hydration of cement is IS 11262 1985, and unit of heat of hydration is calorie per gram or joules per gram, which means 1 calorie is equal to 4.1 joules. Heat produced in hydration process is called heat of hydration, and tricalcium silicate requires 25% and dicalcium silicate requires 21% for hydration, but by SP 23 1982 for Portland cement 23% and 15% require respectively for filling gel pores. So total water to minimum total water required for high heat of hydration is 38%. That particular minimum water required for heat of hydration, which might have been 35 to 38%, is called chemically combined water or bound water. The functions of Bob's compound, the tricalcium silicate, which is responsible for early strength and produces more heat of hydration, which is also known as halide, and the dicalcium silicate, which are responsible for long term strength and produces less heat of hydration, which is called as belite, and the tricalcium aluminate, which is the first compound to react with water and responsible for quick setting, which is also known as silicate, and tetracalcium aluminum ferrate, it gives higher resistance to sulfate attack and also known as phthalate. Testing of cement, field testings and lab testing. The field testings are visual test, adulteration test and strength test, and lab testing, fineness test, Blaine's air permeability test, normal consistency test and setting time test, soundness test, compressive strength test and tensile strength test. Now we could revise something about aggregates. Aggregates also we have seen aggregates are commonly used as filler in the concrete materials, occupy 65 to 74% of volume of cement, volume of concrete. Crushed granites are used as post aggregate, and aggregates reduces shrinkage, classified on the basis of natural classification or based on the basis of classifications on the basis of nature of formation, size and shape. Based on the nature of formation, natural and artificial aggregates. Based on size, fine, coarse, cyclopean and hardened aggregates. Based on shape, rounded, irregular, angular and flaky and elongated. Particle size of aggregates. The particle size of clay is less than 0.002 mm. And the particle size of silt is between 0.002 to 0.063 mm. And the particle size of fine aggregate is equal to 0.075 to 4.75 mm. And the particle size of coarse aggregate is equal to 4.75 to 75 mm. And the particle size of cyclopean are greater than 75 mm. By adding both the particle size of both fine aggregate and coarse aggregate is also collectively called as all aggregate. And now we could additively combine all the water, aggregate and cement are collectively called as concrete. The two types by its mixing, ordinary concrete or nominal mixed concrete, control concrete or design mixed concrete. Classification based on grade. As per IS 456 1978, ordinary concrete are classified as M10, M15, M20 and M25. Controlled concrete M30, M35, M40. As per IS 456 on the year 2000, ordinary concrete are classified as M10, M15, M20, and standard concrete are classified as M25, M30, M35, M40, M45 and 50 and M55, and the high strength concrete are classified as M60, M65, M70, M75, M80. And the classification of concrete by its state are fresh concrete or green concrete and hardened concrete. The properties of nominal mixed concrete are given in the tabulation form. The first column referring the grade of concrete, and the second column referring the proportions for its respective grade, and the third column referring the quantity of water required per bag of cement. And the M5, the proportion is 1:5:10, and the water required per bag is 60 liters. And for M7.5, the proportion is 1:4:8, and 45 liters of water required per bag. And M10, the proportion of M10 is 1:3:6, and 34 liters of water required per bag. and M15 1:2:4 and 32 liters of water required per bag of cement, and for M20 1:1.5:3 30 liters of water required per bag of cement. And water cement ratio, we could study elaborately the water cement ratio by using the code practice IS 456 in 2000, and for elaborate study of mixed design by code practices IS 10262. The other properties of concretes are properties of fresh concrete. The fresh concrete must have to be satisfy these conditions such as good workability, no segregation, no bleeding, lightens and harsh. The properties of hardened concrete are strength, durability, impermeability, shrinkage, creep and thermal expansion. The tests on concrete, the tests to be performed on fresh concrete are slump test, compaction factor test and VB consistometer test, and tests to be performed on hardened concrete are destructive testing, compressive strength test, tensile strength test, and for non-destructive testing rebound hammer test and ultrasonic pulse velocity test. In production of cement concrete are the 3 steps that must have to be performed one by one on an accurate manner to produce an proper mix of cement concrete. The first step was batching, process of proper and accurate measurement of all concrete materials, types of batching, volume batching and weight batching, tolerance of batching. The cement that should not be decreases or increases 1% more than the required, and the water should not be increased or decreased by 1% more than the required, and for aggregate 2% are allowed as tolerance, and for admixture and 3% is allowed as tolerance limit. Okay, whatever be it. Mixing, optimum mixing time is more important. Types of mixing: hand mixing. For hand mixing 10% extra cement to be added, and machine mixing number of revolutions is equal to 20. And then the transportation, placing, compaction, finishing and curing. The steps may gonna change because of the different field varieties and its influencing factors. And admixtures, chemical admixtures are classified as chemical admixtures and mineral admixtures. The most important chemical admixtures are plasticizers, reduces water content, example lignosulfonate, and superplasticizer reduces high range of water, example sulfonate, melanine, formaldehyde, and the accelerator decreases setting time, example calcium chloride, and retarders increases the setting time, example gypsum, air entraining agent increases durability, example benzol resin. The mineral admixtures are cementitious, pozzolanic, blast furnace slag, fly ash, and silica fume, rice husk. And once again the conclusion are, as demand for resilient and eco-friendly building grows, concrete technology continues to evolve. As the construction industry faces new challenges related to sustainability, efficiency and resilience, concrete technology continues to evolve. Have a good day and thank you.